Make it a little bit bigger. Okay, the first thing I want to tell you about this master directory on GitHub, I've kind of reorganized a little bit in the sense that it still have everything. Let me make a clean. -F. Make file. Clean. Okay, I pretty much have still everything like last Thursday when I showed you the first time. But I kind of modified this a little bit. For example, I have this program. By the way, where's it? This program was a program we look at. So I'm going to put it in the same directory, which shows that which lecture I first introduced this code. So go over there, that particular file. You can see that during that lecture, what kind of example or what kind of instruction annotation I put it with the code. So go check out this one. But the other thing which is also important is that you see that there is a two different version of GPS. So this GPS.cpp, GPS.h, it's a very comprehensive version of GPS. It has a lot of other features. For example, how do you handle exceptional handling? So this is, you can think about is you learn all the concept until the end of ecs36b. Then you start writing a GPS, you will write it this way. But at this stage, I want to actually have a simplified version, which we can focus, so we neglect some of the irrelevant detail. For example, we're not using exceptional handling. And also because eliminate that, try to compiling those is easier. Okay, just to let you know, you will see you will see this through the quarter that we will have the file, but we also have a date about a version which we use in class for that, and they're somewhat different. And for this one, and also for the homework assignment one, by the way, 004 for this file, this file, this file, and this file, they're all related to your homework assignment number one. Okay, for homework assignment number one, please look at this. So I actually make another makefile. I call the makefile 004 s2024 because if you look at the makefile, the original makefile, it has everything. It basically compile everything. It compile a way you can design a HTTP server and client. But if you look at the 004 version, is still working, but it's much simpler. You can see that is a lot smaller. It only have a GPS, and you can see here that this is a GPS. This is a GPS 004 s2024. Okay, so it's a lot simpler with this. I'm actually going to tell you this is probably if you never use makefile, this probably will be the first makefile I like to introduce. But this, you can use this for homework assignment number one as well. Okay, this is probably easier for you to do, and it's not that complicated. All right, so just to let you know, that's how we share the information about the software, about the file in this class. Okay, all right, so now let's actually take a look at the GPS 0404. That's why we're looking at this. So this is the class that we looked at last time. And I have something called private and something called public, which I haven't told you what they're about. Don't worry about that yet. But then under the public section, I have a bunch of functions. So the first two functions is called constructor. Essentially, these two functions are the declaration about some program, small segment of program. I will use this program to initialize an object just created. So the constructor, technically, if you actually gradually learn more about the system, you realize that the constructor is not really construct something. It's really about initialize that a piece of memory that was allocated. I mean, you probably heard about malloc and free, right? I assume you know about malloc and free. So constructor is the same, essentially the same as malloc. So when you call the constructor, the system will create a piece of memory to represent the whole object GPS. And then it will invoke the initialization. So when you use malloc, usually the piece of memory that's given to you is unguaranteed its value, and you need to clean it. You need to specify the value in order to use it. So kind of constructor is the extended version of malloc. So it not only include allocation of memory, but also let you initialize the object. Initialization of the object at this stage could be simple, but later when we talk about inheritance, it's getting more and more interesting. Okay, so the two are constructor. So essentially you can see that I have two different ways to construct a GPS object. The first way is just give nothing. That means my GPS, this two coordinate, latitude and longitude, is not going to be guaranteed. But if I use the second constructor, which is I provide two double precision floating point, and then it will initialize when you call it. So let me just look at how this function is getting called. Let's look at the test program. This is a program we show you that, for example, when we say GPS, okay. So for example, if you want to specify an object, integer, by the way, is an object. If you say integer I, so this is a typical C kind of syntax. Is basically allocate some memory, but the integer I doesn't have a default constructor, so it's just like that. But I can do this. I can also do GPS DD, which is the class name, and then I call it GGG. If I do something like this, okay, this is essentially is going to connect to the first constructor, which takes nothing. Okay. However, if you're actually writing this way, that means, okay, this is called bracket initialization. When you put in between bracket, that means those two parameters is going to match one of the constructor that has the input argument match the type. And because these two numbers are both floating point or double, by the way, in C, C++, floating point and double are compatible with each other. So when they match, they realize, okay, I have a constructor with two double, then it will come in. Okay, so before the server crash, I want to say, okay, here. And this is the first time I'm actually coming back to the constructor a little bit later, but I want to tell you the second perspective of a class. I have the other three function. You see that it's called get latitude, get longitude, and the distance. I have a three function, member function. So why is this important about looking at object and go back to the class, and why this is important? Because if somehow I create this object, let's call this object GPS object, and following that definition over here, then I'm expecting that this object must support this particular interface, this three function. So which means that if this object is a GPS DD function, then it should have support this function to calculate the distance between this GPS location and the other GPS location. Okay, so let me just summarize again the two perspectives of class. The number one, class is helping us to create object, initialize, we know that. The second one is that if the object was already created with some class interface, and then we know that based on that class, it was created, or it's related how it's created, then I know what kind of function should be supported. Okay, so the only thing I will tell you later in the quarter is that, well, the problem is sometimes I don't know. Well, remember I said how many class am I related? Here I have a bunch of class, especially I call the inheritance hierarchy. So which means that I have the whole hierarchy of maybe 2,000 different classes, and it was created by one of the class. So it was created over here. I know it's actually from that tree, but I actually don't know exactly which one it was created. This makes the whole object-oriented programming really, really challenging. That's why inheritance is a big topic we'll talk about. But right now, just worry about one class to one object. Okay, so let's. So any question about this two perspective? I hope you just know the motivation about why do we care? Why do we need a class? Why class is so important in object-oriented programming language? Okay, any question? All right, so now I want to give you a challenge. This is a question I prepared for you. No, not here. Sorry. Okay, this is the question I want to ask you today. Okay, this is a question. So, assuming I want to buy something, say I want to buy some Swedish meatball. Okay, I want to buy some Swedish meatball, and assuming it's exactly the same item, I can get it from either Costco or IKEA. I can get the same thing from either one of those places. Assuming their quality the same, assuming the price are all the same, or the tax, whatever, the deal are the same. So the question for you is, well, how do you decide? Will you go to Costco or go to IKEA? Well, okay. What did you say? What? Okay, closer. Okay, so that's good. Okay, let me pull out that you kind of already hitting at the answer. So let's actually first, how many of you prefer IKEA? Why? It has a free coffee, right? I don't know if you know, if you go to IKEA, you get free coffee. Costco doesn't have a free coffee. Okay, so anybody prefer IKEA? Okay, why don't I add 5% to your final grade? Okay, because you are special. I like you. Okay, what's your name? Bernal. Okay, okay. I will find another excuse to deduct that 5 point. Okay, don't worry. All right. All right. So okay, so we calculate the distance, right? So the distance is we calculate the distance between IKEA and UC Davis, assuming you live in UC Davis. And so to find out, which distance is closer. Okay, so I'm going to first run the program and then try to explain how it works. Make file. By the way, because I have the two different make file, when I use make, I have to use the -f flag. So it will compile using this make file instead of the general make file. Okay, that's just let you know. So I'm going to compile the program, and now I have this test. Okay, look at this two line. So TLC stands for teaching learning complex, right? Near the silo, assuming that's our starting point. So I just want to calculate that between Costco and the TLC is 9.3 mile, 9.37 mile. I'm going to show you how I did that. But then between IKEA, West Sacramento, and TLC is about 11.36 miles. So what's your name? Erica. So what Erica suggests is, okay, we look at the distance and decide, okay, this is actually a shorter distance. So that's why I guess all of you decide to go to Costco instead of IKEA, except two of us want to drink coffee. Okay. All right. So that's how we calculate, right? We look at the distance. So now we're going to see how we can actually realize this in the concept. Okay, so first, let's go back to the program. Okay, first I'm going to tell you the constructor. So this 2 lines of constructor, you can see that I already pulled out from the Google map about the GPS location for IKEA and Woodland, Costco. Okay, so I calculate that one. So that's the constructor, that's the GPS DD is a class name. The GPS IKEA Sacramento or GPS Home Woodland, those are the objects, object identifier. So you have a class name, object identifier. That means I actually create this object based on that blueprint of GPS DD. Okay. Now let's see, how do I calculate the distance? So I declare, you can see that the distance 1 is a parameter, sorry, is a variable, is a double. So this is the way I calculate the distance 1. Okay, so let's look at this. If you never saw a C++ or Java program, that this is how it works. So you see that I'm actually making a function called distance. Remember, distance is one of the functions that's specified under the class GPSDD. And I know GPS Home Woodland was created with the GPSDD, so it should have the distance. Okay, it should have the distance. And so when you want to call a function, so if you want to call a function, okay, malloc, you just say malloc. But when you call a member function under some object, you use the object identifier first with a dot and with whatever function you want to call, and then with the argument. Okay, so that's the tradition, how you can call a member function. And let's actually take a look at the member function. How is the member function distance was defined as a function signature. So take a look at this line. So this is the member function. It was declared that the return value of the distance function is a double. So that means the whole thing from here and here is going to return a double. And then I basically, you see that I use a assignment operator over here. So that means that double get to assign to this distance _1. Okay, that's the assignment, the return value, how I should access the return value of the member function. But then the other part is important. You see that this distance function take one argument, and the data type of that argument is GPSDD. That's why you can see that here I have a one argument, and that argument is GPS TLC UC Davis, which is also a GPSDD object. Okay, so over here you can see that how I can use this function to use object identifier dot the function and then follow the function signature. I can basically calculate the distance between Woodland, Costco, and TLC UC Davis. Okay, so that's the syntactically how this works. Okay, any question? Okay, don't hesitate if you have any question. Now let's take a look. Okay, so this is what we call declaration of the function. I just declared there is a member function called distance. Now I'm going to move to see how that function is implemented. So that function is implemented in GPS. CPP. Okay, by the way, the tradition is I always have a .h file, include file, which include only the declaration about the class. But the real implementation, especially those member functions, are all included in the .cpp file. And I will explain later why this is important, because this is what we call is support separate compilation, but also it support a very important feature about protecting your object detail when you release the software. We will get back to this concept a bit later, but let's first take a look. You see that over here, every single function is not just the function name. So what is a GPSDD? This is constructor's name, but I always have GPSDD : in front of whatever function I have. So this part is called class name, and this is the function name. So class plus the function name, that means this function belongs to that particular member function that was declared under that class. So let's actually go to the distance. So the distance must be GPS, DD, : distance. Okay, so you can see that this is the function. You see that the function signature is exactly the same. Return the double. The function name is called distance. And remember, you have to have GPSDD in front to actually specify this is an implementation for that particular distance function that's being declared in the GPSDD class definition. And then I have the one argument, which is a GPSDD another. Okay, so that's now you match from the test program to the GPS.h. Now you actually look at the GPS.cpp file. Okay, all right. So over here, let's say, okay, then the rest is the implementation. You can see that, okay, this is actually, you will say, okay, wait a minute, this is just a one line of code. Really? Yeah, it is one line of code, but I kind of put the detail in another piece of code. I will show you. So essentially, this is implementation of the distance. The distance, that's why I said the function distance is already implemented with this program in this directory. But I want to show you that the implementation of this member function, it calls another function called geodataSource _ distance. Okay, it's actually called another function. And this function takes 5 arguments. This latitude, this longitude, another get latitude, another get longitude, and then there is a single character M. Okay, so you can see that I'm actually calling another function, take 5 arguments. So now I'm going to ask you one question. So now you learn there are 2 kinds of function. One is a regular function, which you learn from ecs36b. And now we introduce another kind of function called member function. That means this function belongs to a certain class. So now I'm going to ask you, this function, geodataSource _ distance, is this a member function or is a regular function? It's a member function or is a traditional function? Yes, in the back. It's a traditional. How do you know? Okay, so you said here you don't have a GPSDD. Okay. Let me do this. Okay. The answer is yes, this is a regular function, but just looking at this function is a bit unclear about whether this is a member function or not. By the way, the correct definition is, okay, if this is okay, how do I say that? Okay, let me clarify this. The first way to look at this is to look at the definition itself. See, here is the function. Here is a function in the same file. I declare geodataSource distance. And when I declare this function, you see that in front of that geodataSources, I don't have any class name. I don't have any class name. It's just like that. So it's about where I define this function and not where I call this function. Okay, by the way, let me actually use an example to show you. Assuming I have a assuming I have a function, wait a minute, why I'm doing like this? Assuming I have a function I call it XYZ. Okay, I just call XYZ. If I write XYZ, do you think it's a regular function or is a member function? It's hard to say. Okay, you have to do this. Let me show you what I can do. I can say void GPS dd XYZ void. And then I say print f hello world. Okay, I declare a function like this, but if I declare a function like this, I also need to change GPS. And I have to add another function called void XYZ void. You see that I'm actually having a function, which is when I call it, you cannot tell the difference. You just XYZ, right? It looks like it's a traditional function, but it's not. Let me actually tell you the tricks here. Let's try to compile this. Yeah, I still compile, and when I run the program, you can see that it actually starts to print to hello world. Anytime you call the function distance, it will actually print hello world over here. Okay, so let me actually there was a few things I should clarify what I'm doing here. I try to tell you this important difference here. Let me go back to my code, CPP. So essentially, this function is a member function. It's under GPSDD. So when you call a member function of the same class, then basically you don't need to provide things like this. You don't need to provide. You're calling your own member function. You don't have to call things like this. By the way, you can actually call this. This way it's fine. Let me actually tell you there are three ways you can call this function. You can call this way. You can call this way. You can call this way. I have to compile using this one. Okay. You can see that all three ways will help me to print hello world. Three different ways. So let's look at, this is just a syntax, but I want you to make a decision about which way you think is the best way. So I'm actually calling a function that is a member function called XYZ. Before I go to the geodata source. So I told you I have at least three ways to call a member function that belong to the same class, which is the GPSDD. The first way is XYZ. The second way is I add a class name. The third way is adding something called this. How many of you have seen this notation, this? Okay. See, I told you I'm going to deduct 5 points from you. No, I'm just kidding. So this is essentially represent a pointer. So what is a this? This is a pointer or memory address to the object. Remember, sorry, you have to start remember, if you really hate the pointer in C, in the contactless C, so I'm sorry that I will try to comfort you to make sure those old hurts won't come back. Okay, that's usually the hardest. But this is essentially the memory address. of the first byte of the object. Remember I said, what's constructor? Constructor is allocate, just like a malloc. You malloc a piece of memory. When you do malloc, what's the return from malloc? Is the memory address of the first byte of the memory that it can allocate. Okay, that's malloc and the free are doing. So essentially, when you say this is the same thing, is the memory address of the first byte of that chunks of memory that's actually going to use for this particular object, GPSDD. So essentially saying that, okay, I have an address and then address pointing to a function, which is, this is sometimes we call a function pointer, and such that this represents a function. So in C++, this is an address, but for beginner, don't see that as a memory address yet. But look at as I want to differentiate this function from the without this. So adding this or not adding this, they're the same to the compiler. But with this, it's clearly that you know that this XYZ is a member function because this is a pointer to the object. And therefore, from the pointer to object pointing to a particular function, the function name is the same as the one of the member function. So this helped the readability. Okay, and I can tell you that there's three different ways. The third way is the most popular way. When people call any member function, especially within the class, this is the most popular. The first way is the worst because it can confuse everybody. I mean, you could have a function called XYZ, which is the same name XYZ, but it's not a member function. And you have a one XYZ is a member function, and you have a XYZ, which is a non-member function, the same name. That's certainly possible. And without putting a this, it's very confusing for the programmer, for the reading of the program. But of course, the system will translate that into here because this is in the context of the same class. This way, I will say it's not as popular. It's actually pretty readable because you know it's a GPSDD. We will use this for a different reason. But let me tell you that why I don't like to use the second way. If you use the second way, if that function XYZ is called a virtual function. Okay, later when you talk about inheritance, and one of the most important concepts in inheritance is called polymorphism. And in C++, how we realize polymorphism is called a concept called virtual function. And later, I'm actually give you some tastes at the beginning, but in the virtual function, you cannot do this. So meaning that this, the third way, will work with the virtual function. But this way, you essentially override the virtual function mechanism such that you lost your capability to do polymorphism. Okay, so just to let you know, there are three different ways. From now on, just use, if you want to call a member function within a function, just always use this. So that, if I know this tradition, then when I look at this code, I immediately know this is not a member function. Why is not? Because if this is a member function, a programmer that's being trained from ecs36b should always do this. If this is a member function, I should always say this to the geodata source. But because I didn't say that, so this is not a member function. Okay, this is not by the syntactic checking. This is by the program convention. It's a very important habit. Okay. Any question? Yes, please.
If we wanted to access, or if we wanted to call XYZ on another object, like this being passed in as a parameter, would you use the arrow access operator or would you use the dot?
Good question. Either way will work. But let me show you this. Look at this. Another is an object, right? It's another object. It's not this object. I call dot get latitude, right? Get latitude is a function below, even though they belong to the same class, but they are different objects. Let me use a different example. Your question is excellent. I want to spend some time to see the difference. Let me go back to this. I have it here. Okay, let's go over here. You see that this is the line. When we call this function, I said GPS home woodland dot distance and the object, right? What's your name? Tyson. Okay, so from Tyson's question, you can see that this is a dot notation. But look at this second line. Look at this line, I commented out. I use the pointer notation. I take the GPS home woodland and put the N. What is the N? N is address. Okay, just this is a very ugly syntax. Only C programmer cares about. Java and the Python people, you're lucky. Okay, so C++. If you have a variable, if you add N in front of that, that means that the whole thing under that parenthesis is an address. Address of the first byte of the object GPS home woodland. So now you can see that by adding that N, I'm talking about this portion. I'm talking about this portion. You see that I add N sign here. By adding that, I turn that object variable into a reference or address to that variable. And because it's a reference, because it's an address, and by the way, C++ even more confusing us by introducing three different concepts. The value, which is the variable, is the value, the reference, and the address. Okay, so now I'm actually going to say this is the address. And because it turned it into an address, which means the address and pointer is the same. And then now I can use this notation. This is the pointer notation. So essentially, I can call it directly from the variable with a dot, or I can turn it into an address, and then I use the address notation pointing to the function called distance, and I can call that. These two lines are exactly the same. It's just I'm using two different ways. Okay, these two are syntactically, semantically are exactly the same. Okay, does that answer your question? Okay. We'll see a lot of those examples when you actually passing. Okay, that's. Let me now. I can look at this. Okay, over here you can see that it's the same thing. I want to put the geodistance. I have a two pair of latitude, longitude. The first pair is this, meaning that from whatever the original object when I want to call this, but then I pass a parameter called another, and then with another, I use another dot, get latitude, and another dot, get longitude. And just to let you know, I can do this. I can do, and let me just copy this. So just if you want to read this code, I'll upload this code, and you can do and another, and then pointing to the get latitude. Okay, so those two are the same. Basically you will see that in C programmer, I have to convert from address to variable for different reason. You will see some valid reason that I have to do this. I feel that sometimes I use a dot notation, and sometimes I will use the pointer notation, especially when I want to handle some of the passing reference to another function. Then I use a lot of pointer notation. Okay. Okay, any question? Yes, please.
And address notation.
I don't think so. I don't think you need that parenthesis. It's also my habit. Whenever I put the and, it's making you understand it's more readable. But I think it's fine. Okay, let me try it. By the way, the way I always not sure about this because I don't know whether I have done this before, but I'm going to do this. I'm going to just do and like this. I feel that the M sign is actually has a higher priority than the pointer. So if I do this, if I do a compiling, oh no, I cannot. Oh, I have to do that. Huh. Good question. So I have to add those parentheses. So see, I make mistake all the time. So remember I told you the only difference between me and you is I have more chances to make a mistake. Okay. So I hope you will make a lot of mistake this quarter, which is the learning. Okay. So I have to put parentheses. Yeah, now it works. Okay. Okay, any other question? All right, let's go back to the code. We're almost done with this function distance. It should be okay, we're here. I'm going to get rid of this. So you know I'm just get rid of this to this. So now the only thing we have is that geo data sources underscore distance, right? That's the only things we have. And that's actually being declared also in the same file. What happened? Okay, here's a function that this function, in fact, I copy this code from this source. It's an open source software from this website, Geodata Sources. And I just copy this function, and then inside the function, it takes two pair of longitude and latitude, and the last one is a unit. Remember, I put a character M. M stands for it will calculate it based on miles instead of calculate based on, I think the other one is K, which is a kilometer. So this is actually going to provide me a double, but it's in miles. So you can see that this function, I'm not going to go through the detail, but this is a function that works, developed by somebody else, is calculating using sine, cosine, this kind of function. You can study the detail yourself. And this is a code, just like this, very short piece of code, and it will calculate the distance for you. And this is a traditional function that's included in the software. Okay. All right, so now we can go back to our program. Now I'm actually coming over here. Okay, this is the line that we talk about. So GPS home Woodland is the object, and distance is the member function. And GPS TLC UC Davis is also an object, but it's also a parameter. That's only parameter needed for the member function distance. And the whole function will return a double represent the number of miles between this pair of address, this pair of longitude, latitude, and this pair of longitude, altitude, and it will return to the distant one. And then it calculates this and realize the distance between Costco and TLC is about 9-point-something miles. Okay, that's how you can actually get this calculation to work. Okay, any question so far? Okay, now I'm actually going to talk about the difference between private and the public. Well, yeah, maybe let's do private, public, then I will talk about constructor. So you can see that I have a two session. One session is called private. One session is called public. So what is a private? Private means that, okay, let me show you a picture about what is the object looks like. Okay, you probably see me doing this, using this diagram a lot. This is a diagram of an object. So when we talk about the object, we talk about there's a boundary. There was a boundary around the data I try to protect. And then I define a few entrants to allow something outside of this object be able to access to this object. So essentially the member function or pretty much everything in the public interface are represented in this picture by this entrance here. And then you see that I have some other data inside here. This data could be the longitude, latitude as an example of GPS.h. Those data are being within the boundary and such that we do not allow any piece of code that's outside of the boundary can access. So this is an important concept for object-oriented, for object. So what's the object? The object is essentially saying that, okay, I want to protect the data in a way such that I want to mandate the way you can access my data. Okay, so just give you an example, if you're doing C programming, let me ask a question. How many of you have experienced some error message called segmentation fault? Oh, great. Okay, that's easy for me. Okay, all right. So what is a segmentation fault? It's essentially we access piece of memory that we're not supposed to access. So essentially, why this will happen is because there's some other error in the code such that you modify the memory in an incorrect way. So essentially, that's saying that, well, if I have some data I want to protect, if anybody can easily access directly, then that's actually going to causing error here and there, such as segmentation fault. So in other words, what we're trying to say is one thing we make a progress in object-oriented programming is that, okay, I really want to protect the data. I don't want the programmer to just use whatever way they want to use a pointer, using whatever. I really want them to use the interface I design. I really want to they use the public interface. So therefore, you cannot directly access inside. Okay, so that's a design of object. So let me use this.